Okay, so now we're going to continue with these problems on 4.2. So on number 21, we have g of t equal the square root of t plus the square root of 1 plus t, and then outside of that you have minus 4. And our interval for this one is 0 to infinity. So again, if you'd rather do it this way, you can say g of x and square root of x plus 1 plus x minus 4. Just whatever works. So our first step is going to be change it to where we can take the derivative easy. And so that would be x to the 1/2 plus 1 plus x to the 1/2 minus 4. And now we can take our derivative easy by putting the half in front and then lower a whole, so to negative 1/2 plus 1/2 1 plus x to the negative 1/2, and then the derivative of x, which is 1, and the derivative of negative 4, which is 0. So what this ends up being is 1 over 2 square root of x plus 1 over 2 square root of 1 plus x. Okay, so continuing with this, you have 1 over 2 square root of x plus 1 over 2 square root of 1 plus x. So what I just did was on my calculator I graphed the derivative, which is the blue one, and I also graphed the original, which is the red one. And so in both cases what you see is that the graph is increasing because on the right side it's up. So what we have is just changing these back to t's real quick. One over 2 square root of t plus 1 over 2 square root of 1 plus t. And so what we noticed was that g of t is increasing in the interval given, increasing for t in 0 infinity. So let's plug in certain values in here. The ones the book chose were 3 and 15. Because when we look at our value here, g of 3 would be square root of 3 plus the square root of 1 plus 3 minus 4. And this ends up being an integer. So the square root of 4 is 2. And so then we get square root of 3 minus 2. And think of that as about 1.73 minus 2. In other words, you're going to get that it's smaller than 0. Another one they chose, just because you can do 15 plus 1 easily, is this, g of 15. And this would give you square root of 15, which is, again, greater than 0. Square root of 15 plus the square root of 1 plus 15 minus 4. So this is square root of 15 plus the square root of 16 is 4. And so 4 minus 4 is 0, so you just get square root of 15. And so in that case, you get that it's greater than 0. So we have one of them that's less than 0 and one of them that's greater than 0. And so we have g of t has exactly 1, 0 in 0, infinity. Okay, so our next one is number 27. And on this one, it says, suppose that f of negative 1 equal 3 and f prime of x is equal to 0 for all x. Must f of x equal 3 for all x? And then it also says give reasons for your answer, which I'm not going to write down. So the question is basically, what would give us a derivative of 0? And we would have, at negative 1, it would be 3. So what we have for this is by corollary 1, by corollary 1, f prime of x is equal to 0 for all x. Then they have this little fancy arrow, which means implies that. So that'd be f of x equal a capital C, where C is a constant. For example, if we had f of 4, what I mean is, if we had f of x as 4, then f prime of x would be 0. If we had f of x equal 3, then f prime of x would also be equal to 0. Because the derivative of any constant would be 0. Since the derivative of any constant is 0. And then the next part is, since f of negative 1 is equal to 3, since f of negative 1 is equal to 3, we have c is equal to 3, which would then imply that f of x equal 3 for all x. So to start with, it could have been either one, just to get f prime equal to 0. That's the part I was emphasizing. But then since we have f of negative 1 is 3, then c did have to equal to 3. So this part and this part are the most important parts in addition to the question. Okay, so that's number 27. Our next one is number 29, I believe. Let me just double check. Yeah, 29. And on 29, this one says, suppose that f prime of x equal 2x for all x. Find f of 2 if, and then there's three parts. The first one is a, which is f of 0 equals 0, and I'll show some work down below. And then b has f of 1 equals 0, and c has f of negative 2 equal to 3. So when we look at this one, corollary 2 says basically we start with g of x as x squared, then our derivative would be 2x for all x. And corollary 2 means it could actually be this plus any number c. Shows that it's g of x equal 2x plus c. So, whoops, not g prime, just g. Let me show that one more time. Corollary 2 shows that f of x would be g of x plus c. So what we get for part A is f of 0 equals 0, that part, which would imply that g of 0 is 0 plus c, which is just c. And c is 0. So when we do this, we'd have f of x equal x squared plus 0. So f of 2 equal 2 squared, which is 4. So those are the steps for A. For B, we have f of 1, and we have that it's equal to 0, which would then imply that g of 1 plus c, g of 1 equal 1 plus c, and so this one we'd have negative 1. How come it's negative? Woohoo! Okay, so before I continue writing this, let's show what corollary 2 is, because we're using that quite a bit. If f prime of x is equal to g prime of x at each point, then there exists a constant where f of x equal g of x plus c for any x in that open interval. And then this is where they're doing f minus g, which is a constant function. So how that relates to ours is we have g of 1 is oh, this should be g of 1 plus c. Okay, that's what happened. Okay. So back here, this should have been g of 0 plus c, and over here, this should have been g of 1 plus c. Parentheses problem right there. This is g of 0 and then plus c, and this is g of 1 plus c. Okay, so that's 1 plus c. And so then c would be negative 1. And so you have f of x equal x squared minus 1. So when we do f of 2, then we get 2 squared minus 1, which is 3. The reason why we're doing f of 2, even though these have different numbers, is it says find f of 2. So find f of 2 if this, this, and this. And so we get 3. Okay, our last part for this one is f of negative 2 equal 3. And so we have 3 equal g of negative 2 plus c. So basically, they're putting the 3 first, and they're changing the f to the g and adding the c. So that's how those are equivalent, similar to how we were doing it there. Basically, as you do more and more of these, it'll make more and more sense. So here we just put the 3 in front, and then the g instead of the f, and then put the c. Okay, so what that leads us to is changing this to say 3 equal what is g of negative 2? Okay, if we're doing g of negative 2, that would be negative 2 times 2, which is negative 4. And so so we get negative 4 plus c. Okay, so what I noticed is this was g prime because I was looking over to the side, 2 times x, but we wanted g of 2, and so using that, that'd be 2 squared, which is positive 4. So we have 3 equal 4 plus c. So then when we subtract 4 from both sides, we get negative 1 equals c. So then we do our f of x equal x squared minus 1, And so that would lead us to f of 2 is 2 squared minus 1, which is 3. Just like the same as up above on that one. Okay, so that's number 29. Our next one is 31. (31) says find all possible functions with a given derivative. And for part A, we have y prime equal x. For part B, we have y prime is x squared. And for part C, we have x cubed. Y prime equal x cubed. Okay, so what we're doing is we're trying to go backwards. And so just remember, like, some examples. If we started with x to the 4th, it'd be 1/4 x cubed. If we started with x cubed, it'd be 3x squared. If we started with x squared, it'd be 2x. And if we started with x, it'd be 1. And if we had some number like 5, then it'd be 0. So this is just an example, and we need our derivative to be equal to x. So that means we're going to have some sort of x squared function in there. So what we need is to just guess and check with x squared and then other numbers in front. So if we had f squared, then it'd be 2x, but we have x. And so if we're going to need to cancel out the 2, then we have to put a half in front. So then if y equal 1/2 x squared, then that would be like x squared over 2. Then it would be x. And that's what we're going to end up wanting. So our answer for this is y equal x squared over 2, and then don't forget you have to have plus c, because it could be any constant after that. So in other words, if we had x squared over 2, then it's x. But if we had x squared over 2 plus 1, then it would still be equal to x, or any other constant, any other number instead of 1. And so that's why you're going to have the plus c. Okay, so since there was no coefficient in front, we had to go up to x squared, and then we had to divide by 2. So we're going to have to do that with this one also. For B, we're going to guess and check with x cubed. And again, when I did x cubed, it's 3x squared. So if we have y equal x cubed, then y prime would be 3x squared. So what we need to do is just use our 3 So we're going to have y equal 1/3 x cubed. That would make the 1/3 times 3 cancel out, and then that's what we want. So our answer for this one would be y equal x cubed over 3 plus c. So now I think you're getting the hang of it. For this one we have y prime equal x cubed, and so if we try x to the 4th, we'd really need 1/4 x to the 4th, and then plus c. So we always bump it up a power and then add c, and it's 1 over that. So this is all as 1 over n x to the n plus c, since there was no coefficient. Well, since there was no coefficient other than 1 that was given in our problem. Okay, that was 31. I think our next one is 33. Just double check. Yeah, 33. And on this one, we have a is y prime equal negative 1 over x squared. We have b is y prime equal 1 minus 1 over x squared. And on c we have y prime equal 5 plus 1 over x squared. So for this one we're going to have to work backwards. So we have y prime would be negative x to the negative 2. And so again, when we're going from our derivative to the function, then we work backwards. And so start with 1 over x, which is x to the negative 1. If we do that, then you put your negative in front, put your x, and then lower a power. And so that worked. And so our answer is y equal 1 over x plus c. Our next one, if we're working backwards, you want to start with x in front, because the derivative of x would be 1. And for this other part, it was minus 1 over x squared for this one, and that's what we have here. And so we'd need start with x plus 1 over x. So this is x plus 1 over x plus c. And on this last one, start with 5x, because the derivative of 5x would be 5. And then this one has a sign change from a negative to a positive, so we're going to need a negative and 1 over x. So we need y equal 5x minus 1 over x plus c. Okay, so now we have 37 and 45 left. So on 37, it says find the function with the given derivative find the function with the given derivative whose graph passes through the point P. And on 37 we have f prime of x equal 2x minus 1, and the point is just 0, 0. So the first thing we want to do for this one is try x squared minus x. So f of x would be x squared minus x. So in other words, the derivative of x squared would be 2x, and the derivative of negative x would be negative 1, and we need a plus c. So that's what our function is. Remember, this is our derivative, and this is our function. Now, as we do more of these in later lessons, it's also called an antiderivative because it's the opposite of the derivative, and it's also called the integral. INTEGRAL. And that's when you start with a function and start with the derivative and get your function. So the integral part would be like the integral of 2x minus 1 is x squared minus x. So, and then plus c. So what they're trying to show you is by doing these lessons and putting plus c that you'll remember when you do integration that you would have a function with dx because it's derivative with respect to x, and you just work backwards like we're doing here for the first time. Okay, so we figured out our original function by working backwards, and the next thing we need to do is plug in 0. So f of 0 would be 0 squared minus 0 plus c, which implies that c is 0. And so your f of x would just have to be x squared minus x, with nothing else after it. Okay, and let's see, our last one, 45, and on 45, give the acceleration a. Remember several lessons ago we talked about acceleration, velocity, and position? Well, the acceleration is the d squared s dt squared. So in other words, acceleration is the second derivative of position. Second derivative of position. So we have acceleration is d squared position over derivative of time squared. We also have the initial velocity, and the initial position. Initial position. And it says find the position at t. So specifically on 45, you know A is 32, V of 0. So the initial velocity would be 20, and S of 0, or the initial position, would be 5. I'm going to abbreviate these. Well, whatever. The initial velocity and the initial position. So those are the things we were given. Make sure you put this part. Okay, so that's what we're given, and so the main thing you need to know for this one is for acceleration, you're going to use e to the x. For acceleration, you're going to use e to the x. And so acceleration is dv dt, or you could say v prime. And that's going to be e to the t. Now, what that would lead us to, if you work backwards to get your function, is v would be e of t plus c. And so at v equal 20, which is what we were given, at v equal 20 and t equals 0, we would have c equal 19, because basically 20 equal e to the 0 plus c, and e to the 0 really gets replaced by 1, because anything to the 0 power would be 1. And so our c would have to be 19. And so what that implies is that our constant there would have to be 19. So v equal e to the t plus 19. And then that's our velocity. Now for our position, we've got to go one level back. And so that would be e to the t plus 19t plus c. So again, just as a chain, we're thinking position, then velocity, then acceleration when you're doing derivatives. And the other way is acceleration going to velocity, going to position. And so those are how we're working. Okay, so the other thing I should mention is if you have e to the t, the derivative of e to the t is just e to the t again. I mean the antiderivative. The antiderivative of e to the t is e to the t. The antiderivative of e to the t is e to the t. So basically, if you have this, then you put it there, and then this, you put your variable. So then all we have remaining is to plug in s equal 5 from this. So 5 equal e to the 0 plus 19 times 0 plus c. And this is 5 equal 1 plus 0 plus c. Therefore, you have c is 4. And so that means s equal e to the t plus 19t plus exactly 4. Alright, so that'll be the end of 4.2.